All right. One thing I want to talk about a little bit before we continue is the notion of polymorphism. Polymorphism is a concept. If you look at the word, the origins of it in Greek, poly means many, morphism means forms. So we can talk about objects taking many forms. And what do I mean by this? Well, we've had an example of this where we had, I believe we went over it in week 7, where we have our pizza class, and extending the pizza class is a stuffed crust. And the stuffed crust, we overrided one function in it. We overrided the calculate price because the price of the stuffed crust pizza was more expensive than the price of a regular pizza. Now, because the stuffed pizza is a pizza, we can treat it like a pizza. So in other words, this function here, add pizza, that accepts a pizza for an argument, it accepts any kind of pizza as an argument. So pizza or any class that inherits from pizza can be accepted as an argument. So it can take many forms of the pizza. All right. So we saw that here where we've said we created our stuffed crust pizza up here, somewhere, right here. And we added it to the order. We ran the order add pizza method. Now, it can accept many forms, and each form is going to be treated appropriately. What I mean by that is, if we ask for the price of the pizza, if we ask the price for a regular pizza, it will use this algorithm in computing it. However, if we ask the price for a pizza and that pizza happens to be a stuffed crust pizza, it will, even though in the array list is defined as simply being a pizza, if it was a stuffed crust pizza that got passed into the add method, that pizza will get calculated using the stuffed pizza's calculate price algorithm. So by saying it's a pizza means we can call any function that's declared on the pizza class, but we will get the proper version of it depending on the type of pizza that the particular pizza is. So many forms, all right? We can treat anything that inherits as a pizza, as a member of the pizza class, because it too is also a pizza. We can call any function that exists on the pizza class, on any pizza. However, we will get the proper version of the method depending on the kind of pizza that was created. Okay, that's kind of polymorphism in a nutshell. If you look out and do a search for Java polymorphism, it speaks in more formal terms. Java polymorphism refers to the ability of a class to provide different implementations of a method depending on the type of object. You perform the same action many different ways. So we can calculate price on any pizza, but we'll either use the stuffed crust pizzas calculate price, or we will use the regular pizzas calculate price. All right. So consider this situation. Let's say for whatever reason, my application needs to deal with animals. All right. So we're going to be creating classes about different animals. I'm not going to go into any more details because this is sort of just a thought experiment. We're not actually going to create these different classes. As you might imagine, we could have as a superclass animal, because all animals share certain characteristics. All animals have a birth date. All animals have a weight. And so on. So we might inherit from animals a bird class, a mammal class, a fish class. And inside the bird class might be the eagle, and a pigeon. And inside a mammal class might be a bat and a cat. And inside the fish class, there might be salmon, perch. All right. As you see that we can apply the is a rule to all these. A perch is a fish. Fish are an animal. A cat is a mammal. Mammals are an animal. And so all the way up this. For all of these, the is a rule applies. And another word for inheritance is specialization. In other words, animal is a very generic term. Bird is a more specific version of that. Eagle is an even more specific version of bird. So bird is a more specific animal, eagle is a more specific bird, and we might be able to create subclasses going down that gets whatever degree of specialization we want. Now we can define some of these as abstract, and we can also do that with methods, which means that if I create an object, I cannot, if I create this as an abstract object, I cannot say animal A equals new animal. That's not allowed because that's an abstract class. I could say something like animal A equals new cat, however. All right. Now let's say that I needed to account in my system for two other kinds of animals. Flying animals and swimming animals. All right, where would I put this in the diagram? Well, that's a tough question because do I inherit birds from flying animals? Well, not really, because there's other kinds of animals that are flying that are not birds. For example, bat. And besides, I can't, in Java, there's no such thing as multiple inheritance. So I can't, for example, have bird or have bat inherit from mammals and from flying animals. I'm not allowed to do that. That's multiple inheritance. That would get really confusing because you wouldn't know what methods, what constructors, anything like that to call. All right, so multiple inheritance is not the answer. You cannot inherit a subclass from multiple classes. And yet, there are still some behaviors that exist for flying animals that I might be interested in my application. Namely, what is their wingspan? Assuming they have wings. Well, let's assume that they have wings for now. What is their maximum height that they can fly? What is the maximum speed that they can fly at? And likewise, swimming animals are the same way. could I inherit fish from swimming animals? Well, maybe, but other animals can swim too, right? Otters can swim and they're not mammals. Whales can swim and they're not mammals. So the answer isn't double inheritance. There's what are called interfaces. And don't think of interfaces like a graphical user interface. That's not what the word interface means in this respect. Interfaces, first of all, are abstract classes, which means you cannot create an instance of them. So I can't say flying F equals new flying, all right? And this is the way that traditionally interfaces were. There have been some enhancements to interfaces that we won't cover right at this moment. But what an interface is a contract. In other words, it is a guarantee that whatever classes implement that interface will have a certain number of methods, and we can define those methods. Might be one method, there might be several methods. But when we define an interface, we are saying that, yes, every class that implements that interface has to have these methods. So what is the advantage of that? The advantage of that is that we can treat those classes polymorphically. So for example, if I decide that a swimming class needs to know the maximum depth and the maximum speed. Maybe that's two things that I'm interested in, all swimming animals. I want to know how deep they can swim, and I want to know how fast they can swim. If I declare the interface, and it's not a class, it's an interface, as having these methods, then anything that implements that interface has to implement these methods because they're abstract. And with an abstract method, anything that you instantiate has to, anything that's not an abstract method, has to implement, or an abstract class has to implement that method. So if I say that fish implement swimming animals, and I'm going to show that with a dashed line instead of a arrow. If I say that, then any fish has to have a get maximum depth and a get maximum speed function. Likewise, if I were to say that bats are flying and eagles are flying and pigeons are flying, then I might have sort of the same thing, get maximum height and speed. If I declare those methods on the flying animal interface, then anything that implements that interface has to have these methods. Then I can treat it polymorphically, just like I did with the pizzas. I can pass it to a function that requires a flying animal or a swimming animal, and I know that anything that implements that interface has those two methods, so I can call those two methods and get the proper version of those methods. Okay, that's what we mean by an interface. I have an example, more concrete, if you pardon the pun, to implement here. I have a application, little mini application, where I have suppliers and students. All right. Let's say this is for a college, and I only did a couple of classes in this hypothetical problem. Let's say I'm a college. A college, I have faculty And there can be different types of faculty, adjunct, and full-time. There are students. They're the people that we spend money on, the suppliers. For example, people that we buy the food from for our cafeteria, people that we buy our furniture from, and so on. And finally, well, that's the only examples I have. Could be community members. All of these have their own classes or have their own attributes and methods. So a student might have a register for a class method, a student might have calculate tuition method, and so on down the line. Faculty might have assigned to a class teaching method. Faculty might have, get paycheck. A faculty might have get sick time or something like that. Supplier doesn't have sick time. All right, there are people that supply the college with materials. And a community member doesn't get any sick time from Lorraine Community College either. So none of these things have anything in common. All right, they're not even all people, right? A supplier is an organization. It's not a person. But there is some behavior that all these things have in common. And that is we might want to email them all. Or we might want to send them regular mail. All right, in this example, I only include email, but possibly two things might be that I would want to email this person or this entity, or I might want to send a regular snail mail to this person or entity. So there's some common behavior that I want to implement. And I want it to be polymorphic. So if any of these are passed to a function to send an email, then I can get the email address to send the email. So I'm going to create an interface called emailable. And it's going to be implemented by these four different entities. Now, in this example, coding-wise, I only implement two of these. But I should be able to implement as many emailable things as I want to, regardless of where this sits on the inheritance structure. So there might be person class up here that these two classes inherit from. Or suppliers doesn't inherit from the person class because it's not a person, and so on down the line. So this emailable interface, I can implement on any class regardless of where it sits in the inheritance structure. Now, implementing an interface is different than inheriting from. It's different because we don't get any code. We just get the ability to treat it polymorphically. So by inheriting something from a superclass, we get two advantages. We can treat it polymorphically, and we can share code. We can write code on one level that gets inherited by its subclasses. We don't get that ability to inherit code for the most part. There's a few exceptions, but in the old school way of dealing with interfaces, we don't get the ability to inherit code, but we do get the ability to treat it polymorphically. All right, so let's look at the example. My interface, which is emailable, I define not as a class, but as an interface. And I have just the signature of the function. The signature of the function is, in this case, well, in all cases, the name of the function, any arguments, and the return value. So anything that implements this interface has to have this function in it. It doesn't matter what the body of that function consists of. All right? But it has to have some value for it. So let's look at my two different implementers. Here's my student class. They have two properties, a first name and last name. I'm going to pretend their email address equals their first name dot last name plus @mail.lorainccc.edu. And then I'm not actually going to send an email, but I'm going to just write to the council that I've sent through the email, and I've returned a 0. Really, what would probably have is would have some kind of code that indicated that it sent the mail successfully or did not. Let's look at the supplier. The supplier has as an attribute the email address. And this send email function simply outputs and says that we've sent an email and also returns a hard-coded 0. Again, in a real application, it would actually go through the mechanics of sending an email and return some sort of status code based on whether the email was sent or not. Now, how do you implement an interface? You say public class, whatever the name of the class is, and you say implement emailable. A class can implement as many interfaces as you want, but a class could only inherit from one superclass. So public class supplier could extend some other class if we needed to. And it could implement emailable, phone callable, snail mailable, or any other behavior that we wanted it to. When we do that, when we say implement it, we have to have the function that was defined in the interface. So here we just have the signature of the function. Here we actually have to have the body of the function. Let's look at what our test case does. Our test case creates a new student, sends email, creates a new supplier, and sends email. Save this and compile it. Okay, I got a problem. Let's take a look at that. See what the problem is. The error says that student is not abstract and does not override abstract method. All methods in an interface are abstract. So let's see what the problem is. Oh, I spelled email wrong. All right. Now that's an important thing to note though. Because I said that this implements the emailable interface, that means the student class has to have all these functions in it. When it didn't, because I spelled email wrong, I get an error saying that it doesn't override the method. So I'll correct it and save it and recompile it. And run it. Send email to Mike Zellers at mail.loraineccc.edu or email sent to mz@mz.com. Now you might say at this point, so what? All right. We could have done this without creating an interface. We could have simply put two functions on these called send email and not used an interface. In fact, let's do that. Let's get rid of this implements emailable and see what happens. Well, I can't say that for one thing. I can't say emailable, but I could say student and supplier. I couldn't say emailable because I'm no longer is a student or supplier emailable. And the results look the same. So what's the big deal about making it emailable? First of all, I can treat these as emailable. That is, I can do this. Create a variable that's of type emailable. And that will work because it implements emailable. That means that it is emailable. Think of interfaces as also the is a test, but it's sort of a weaker version of the is a test. Like a bat is a mammal. But by the way, a bat is also a flying animal. So the by the way, extra sort of thing is what we would do interfaces for. But here's another thing I can do. I can create an e-list, just like I did in the order class. I can create an array list that contains emailables. So I can come up with a list of emailables in my program. And let's say I want to send every person on my email list, whether they're a supplier, a student, or any other type of entity that I can email. Let's say I want to send them an emailable encouraging to vote in the upcoming election. I could create a single list of emailable things. So I could create the array list. And I can add to that list S and V. I can do that because S and V are both implement the emailable interface. Just like I could add in the previous example, any kind of pizza, whether it be regular or stuffed crust, I could add it to the order, which had a list of pizzas. I'm going to need to import the array list in here. So I have to do that because that's not a standard part of Java. It's not in the Java basic core. I have to say, hey, I want to use the array list in this program. So so I have to tell it that, hey, I want to use the array list. Now I should be able to compile and actually loop through the array list and output This is a newer type of syntax. I forget how to do it precisely. So for each emailable thing that exists in my list of emailables, I can say send the email. I'll get rid of these send emails. Do it here. Put the import in the wrong place. Line 22. Oh. Somehow I got one extra. Those. And we get send email to Mike Zellers as a student or send email to mz@mz.com, the supplier. Now here's the idea. Constructing the email address in this case could be different for every single emailable thing. In the case of supplier, email is just an attribute. In the case of student, the email address is simply combining their two names together. For faculty, there might be another rule. for creating it. But in any case, if we make something emailable, it has to implement that interface. So let's make a faculty. Make a faculty class. I'm going to make a faculty class. And I'm going to do this a step at a time. I'm going to make some mistakes along the way. Let's say that each professor's email address is the word professor, followed by their last name and first name. We compile to make sure that I have not made any mistakes coding wise. All right. So now I'm going to try to create a faculty member in my unit test class and add them to the array list. Just like I did with the student and with the supplier. I'm going to say faculty F equals new faculty we'll be more official here and use my full name of Michael. Is this legal? Yes, it is. So far, so good. Let's go and try to add that to the list of emailable people, to the email list. So this is going to give me an error. Let's see if we can figure out what kind of error we're going to get. I get an error and it says that faculty cannot be converted to emailable. All right. Why not? Well, if you look here, I didn't specify that a faculty class implements the emailable interface. So I have to do this, implements emailable. I'm going to change this function to send an email for a second. I meant to do that right off the bat. So I make it implement emailable. I try to compile this again. It's going to give me another error. Why? Because I promised that faculty implements the emailable interface. And what implementing an interface is the promise that you are going to implement all of these abstract methods. By definition, an interface is an abstract class, and all its methods defined here are abstract methods. So I lied to the compiler. By telling that it implements the emailable interface, I promised I would have all these functions in the class, and I don't. So I would have to make sure that it implements that. Now, I should be all set. And sure enough, I can. So in a nutshell, interfaces allow us to treat different things that have something in common, allows us to treat them as a unit. It allows them to, not as a unit, but allows us to treat them as having something in common. Allows us to treat them polymorphically is probably the best way to put it. Now let's look at your assignment coming up. Should be lab 9. Let me edit this. Remember again, if you have not contacted me to let me know where you're at in this class, because there's a number of you that are behind. Lab 8 says you need to do that by October 19th. That's this Wednesday. So please contact me. Let me know where you're at. Let me know what you need to get back on track. And let me know how I can help you get back on track. This is important because I'm very flexible about my due dates. However, there is a day of reckoning coming up, and that's the end of the semester. And your material needs to be completed by the end of the semester. That's one thing I can't do unless there's really unusual circumstances is extend the semester. Anyhow, Lab 9 says, create an interface for AC power devices. The interface will have two methods, get kilowatt hours, which returns a double, and toString that returns a description of the device. So this shows you the different things. So you're going to have one interface called AC powered devices. You're going to then, and that is going to have two functions on it, toString and get kilowatt hours. Those functions will not have any code behind them because for each thing, we're going to implement those functions differently. So for a light bulb has wattage. And you calculate the kilowatt hours by dividing the wattage by 1,000. The toString should say light bulb blank number of watts, or XX is the wattage. For electric blanket, there's a size, default to queen, and there's a setting on the electric blanket, 0 through 10. And here's how you calculate the kilowatt hours. If it's twin, it's 100 times settings, divided by 10, divided by 1,000, queen, king. And toString should say electric blanket, this many kilowatt hours at Y. If you notice, each one of these different devices have a different way of doing the calculation and a different format to the toString in different attributes. So each one of these should have the attributes as defined, but all of them need, in addition to whatever other methods you have, all will need to get kilowatt hours and toString. And then your job is to do what I did, create an array list that contains AC power devices, create some of each device with different values, then loop through the array list, call the toString method to identify the device, and then display kilowatt hours that was calculated. Are there any questions to this? Now, I did mention that there's been some changes in recent versions of Java concerning interfaces. They've added a static method and a default method. We don't really need to worry about that. in this example. Just be aware that and there's constants that have been added, abstract methods. And so on. So just notice that there has been some changes from what I've talked about, but this is sort of the basics of interfaces. This is mainly what interfaces are used for. Some of the more finer points, you know, you can address as you continue to study Java. All right, that's all I had for today. Again, it is critical that you talk to me about where you are in this class and how we can get you back on track. So please be sure to complete Lab 8, regardless of where you are otherwise in the class. That's all I had. As always, if there's any questions, please let me know. Have a good week. We'll talk to you next week.